student asked me a doubt. Let me take out that concept at the beginning. Student doubt. Listen carefully to this beautiful concept, sir. Concept or concepts we will write. Concepts. First concept. Let me take, suppose I do not have money. I need 100 rupees. I went and asked my friend 100 rupees. He gave me some money, which is 100 rupees. P is 100. He said, hey, Anil, you are using my money, so you have to pay me extra. I said, how much I have to pay you extra? He said, for every 100 rupees, you need to pay me 10 rupees extra. Now, what will happen? It is in compound interest. It is in compound interest. Amount after first year will be, amount will be principal plus compound interest. 100, 10% of 100 is 10. So when I am meeting him after 1 year, in addition to the sum took, I will give 10 rupees extra. 100 plus 10 is 110. 100 plus 10 is 110. Next one, amount after 2 years. 2 years it will be 10% successively 2 times is 10 plus 10 plus 10 into 10 by 100, which is 21%. 21% on 100 is 11, which is 21% of 100 is 21. On 100 overall it is increase of 121. Next again, amount after 3 years. So it is 100 into 1 plus 10% power 3. 10% 3 times successively. It is 33.1. So it is 133.1. 133.1. Amount after 4 years. It is 100 into 1 plus 10% power 4. We already did it by using Pascal's triangle also. It is 146.41. It is 146.41. Amount after first year is 100 into 1 plus 10%. It is 100 into 1 plus 10% power 2. 100 into 1 plus 10% power 2. Now listen carefully to this very, very important key point. Suppose if I observe A1, A2, A3, A4. A1 value it is 110. A2 value it is 121. A3 value it is 133.1. A4 value it is 146.41. 146.41. 110 to 121. It is into 1.1. It is into 1.1. It is into 1.1. That means A1, A2, A3, A4. A1, A2, A3, A4. And so on up to. And so on up to AN. They are in arithmetic progression. Please write down. A1, A2, A3 and A4, AN. They are in arithmetic progression. They are in arithmetic progression. They are in arithmetic progression. First key point, it is clear. Amounts at the end of the year, they are always in arithmetic progression. For example, if I say 2, 4, 8, 16, 32. 2, 4, 8, 16, 32. They are in geometric progression. Common ratio, it is common. It is not, that's a wrong usage of word. It is in geometric progression. 100 into 1.1 is 121. 121 into 1.1 is 133.1. 133.1 into 1.1 is 146.41. Multiplication factor, it is the same. Or 121 by 100, 133.1 by 121, they are also same. 2, 4, 8, 16, 32. They are in GP. Can I say that 2, 8, 32? They are also in geometric progression. Yes or no? Right? If the series is in geometric progression, first term, third term, fifth term, as long as the difference in the right number of terms it is same, they will be in geometric progression. So not only A1, A2, A3, A4, AN, they are in arithmetic progression. A1. If I take A3, gap is 2 years. A5, they are in arithmetic progression. Are you all with me? Suppose if I take A2, then it is A7, then it is A12. They are also in arithmetic progression. They are also in arithmetic progression. As long as the gap between them, time period, if it is the same, time period A1 A3 A1 A3 110 133.1. Multiplication factor will be 1.1 into 1.1 1.21. Here onwards it is 1.1, again it is 1.1. So 133.1 into 1.21, I will get A5. A1 A3 A5, they are in AP. A2 A7 A12, they are in, sorry, again I am doing the same mistake. It is in GP. It is 1 minute, sir. I made a mistake here. This is in geometric progression. This is in geometric progression. Here also it is in geometric progression. Here also it is in geometric progression. Geometric progression. Am I right? Geometric progression. Now, listen very, very carefully, sir. Listen very carefully to the derivatives of this concept. Compound interest behaves in geometric progression. We have discussed this concept. Today, we will solve a good number of problems based upon this concept. I hope this concept, it is clear. It is in geometric progression. Another observation. Now, principal, it is 100. Amount after first year, it is 110. Amount after second year, it is 121. 121. Amount after third year, it is 133.1. 133.1. Now, listen very carefully, sir. Suppose if I take the ratio of P is to A1. P is to A1 ratio is 100 is to 110. 100 is to 110. So, this is there in the ratio 10 is to 11. P is to A1. Successive terms ratio. It is in the ratio 10 is to 11. Now, if I take A1 is to A2. A1 is to A2. It is 110 is to 121. 110 is to 121. 11 tens are 110 and 11 11s are 121. Are you all with me? Suppose if I take A2 is to A3. So this will be 121 is to 133.1. 133.1. Even if you do it, 12.1, if I divided by 12.1, it is 10 is to 11. 10 is to 11. Very, very important key point. If P and A1 are in the ratio X is to Y, A1 and A2, they are also there in the ratio X is to Y. A2 and A3, they are also in the ratio X is to 5. A3 and A4, they are also in the ratio X is to 5. Please write down this important point. Write down in the important point. Amount after 2 years, amount after 5 years. If it is in the ratio 2 is to 3, amount for A5 is to A8, it is also in the ratio 2 is to 5. 2 is to 5. If the series is in geometric progression, ratio between the consecutive terms, it is same. So always it will be of the form. Best way to solve it is, because it is in geometric progression, take a series 2, 4, 8, 16, 32, 64. These there in the ratio 1 is to 2. These there in the ratio 1 is to 2. 1 is to 2, 1 is to 2. Are you all with me? This is an extremely important concept. Whenever we are solving amount after 2 years it is given, amount after 5 years it is given, amount after 8 years in compound interest we need to compute. Amounts at the end of the year will always be in geometric progression. Amounts at the end of the year will always be in geometric progression. In a geometric progression, ratio between the consecutive terms, it is constant. Ratio, it is constant. Sir, are amounts only at the end of the year, will they be geometric progression, or any other values will be in geometric progression? Now, another very, very important, what is this ratio we got? 1.1. Here also 1.1. Here also 1.1. What is this 1.1? 1.1, it is nothing but scaling factor, which we did it in our previous classes, which is 1 plus r percentage. So what is the common ratio if the series is in geometric progression? If the series is in geometric progression, the common ratio is given by scaling factor. Please write down in your notebook. If amounts at the end of the year, if they are in geometric progression, if amounts at the end of the year, if they are in geometric progression, then the common ratio is given by scaling factor. What is scaling factor? R percentage more. Rate of interest is defined as percentage increase. Percentage increase, it is always 1 plus R percentage. This is an extremely important key point, sir. Very, very important key point. Sir, our amounts only will be in geometric progression, or anything else will be in geometric progression. Listen carefully, sir. Listen carefully. Key point 2. Please write down, sir. Key point 1. P, A1, A2, A3 and AN are in geometric progression. Key points. Second key point. Principal equivalent to 100. R percentage equivalent to 10 percentage. Amount after first year, it is 110. Amount after second year, it is 121. Amount after third year, it is 133.1. Amount after fourth year, it is 146.41. We are doing under compound interest. We are doing under compound interest. We are doing under compound interest. Now, let us find it out. What is the compound interest for first year? What is the compound interest for the first year? What do you mean by compound interest? It is the extra sum we gave in addition to whatever we took. I took 100 rupees from my friend. After 1 year, I gave 110. That means how much extra I gave? Extra I gave, it is a 10. CI for first year, it is a 10. Are you all with me? Next, it is in CI for second year. See, there is a difference between CI for second year and CI for 2 years. CI for second year is, in that second year, what is the extra money which I am giving? CI for 2 years means, for total 2 years, what is the extra money which I am giving? CI for second year. CI for second year. Listen carefully, sir. CI for second year. 110 to 121. Amount at the end of the first year becomes the principal for the second year. So in the second year, I started with 110 and I completed with 121. How much extra I gave? Again, it is 11. What is 11? 121 minus 110. Amount at the end of the second year becomes the principal for the third year. That means it becomes the input for the third year. Beginning it is 121. Ending it is 133.1. That means CI for third year. CI for third year. CI for third year, it is 133.1 minus 121, which is 12.1. Which is 12.1. Next one, CI for fourth year. CI for fourth year. What do you mean by CI for fourth year? CI is the extra interest I paid it in the fourth year. Amount at the end of the third year becomes the principal for the fourth year, 146.41 minus 133.1, which is 13.31. 13.31. I hope this idea it is clear. I am not doing the total CI for second 2 years. I am not doing the total CI for 3 years. I am doing the CI for second year, CI for third year, CI for fourth year. Very, very beautiful conclusion. 10 is becoming 11. It is into 1.1. 11 is becoming 12.1. It is into 1.1. 12.1, it is becoming 13.31. Again, it is 1.1. So the multiplication factor, it is the same. Multiplication factor, it is the same. Or the ratio, it is the same. That means CI for first year. CI for first year. CI for second year. CI for second year. CI for third year, CI for third year, and so on for CI for nth year, CI for a particular year, CI for nth year, all are also in geometric progression. Very, very important point, sir. Very, very important point. So not only amounts at the end of the year, they are in geometric progression. Compound interest at the end of a particular year, they are also in geometric progression. CI for first year it is 10, CI for second year it is 11, CI for third year it is 12.1. How you got 11? Amount at the end of the year becomes the principal for the second year. 110 is becoming 121, extra it is 11. Amount at the end of the year becomes the principal for the third year. 121 is becoming 133.1, difference is 12.1. 10 multiplied by 11, it is 1.1. 11 multiplied by 1.1 is 12.1. Similarly, multiplied by another 1.1, it is 13.31. CI for first year, CI for second year, CI for third year, CI for nth year. They are also in geometric progression. If the series is in geometric progression, then the ratio between consecutive terms will be constant. Consecutive terms will be constant. So what is the ratio? 1.1. What is 1.1? It is 1 plus 10 percentage. 1 plus 10 percentage. So the common ratio is given by scaling factor. What is scaling factor? It is 1 plus R percentage. Common ratio, it is given by scaling factor, which is 1 plus R percentage. Whether it is amount or whether it is compound interest for a particular year, whether it is amount at the end of a particular year or the compound interest at the end of the particular year, the common ratio is always the same, and that is given by 1 plus R percentage. That is given by 1 plus R percentage. CI for first year, CI for second year, CI for third year, CI for third year. Suppose I got CI for second year. CI for second year, some value it is given. R percentage it is given. I want CI for fourth year. So second year to R, third year, what is the common ratio? 1 plus R percentage. Third year to fourth year, what is the common ratio? 1 plus R percentage. Very, very, very important key point. First we will do it for a particular year. In the last advanced session of compound interest, I will do it for CI for 2 years value it is given, CI for 4 years value it is given. Then we will see the behavior. For this class I will do till a particular year. I hope it is clear. Now a student will ask me, sir, CIs for a particular year, they are in geometric progression. For a total number of years, are they in geometric progression? Let us see it. Next key point. Key point number 3. Once your concepts are clear, then you will be able to solve a lot of questions very, very easily. Key point 3. Key point 3. Amounts for a particular year in a serial order are in geometric progression. Compound interest for a particular year in a serial order, it is also in geometric progression. If P equivalent to 100, R percentage equivalent to 10 percentage, R percentage equivalent to 10 percentage, amount at the end of 1 year, amount at the end of 1 year, which is 110. Amount at the end of 2 years, amount at the end of 2 years, it is 121. Amount at the end of 3 years, it is 133.1. Amount at the end of 4 years, it is 146.41. Amount at the end of 1 year, it is 110, 2 years, it is 121, 3 years, it is 133.1, and 4 years, it is 146.41. So what we are doing right now, it is, we are calculating the compound interest for entire 2 years. We are not doing it for a particular year. We are doing it for the total number of years. For total 3 years. Compound interest for the total 4 years. We are trying to see whether it is in GP or not. So CI for the 1 year. 100 is becoming 110. Extra it is 10. CI for 2 years. What is the difference between CI for second year and CI for 2 years? When I say CI for second year, I am referring to the extra money which I gave it to my friend only in the second year. When I say CI for 2 years, the total extra money which I gave for the entire total 2 years, 121 and 100, which is 21. CI for 3 years. Finally, initially principal is 100. After 3 years, I gave 133.1. So extra how much it is? 33.1. 33.1. Initially, I took 100 rupees from my friend. After 4 years, I gave 146.41, which is 46.41. 46.41. So 10 is becoming 21. It is into 2.1. But is it into 2.1? It is not equivalent to into 2.1. 21 whole square is 441. So 21 into 2.1 is 44.1. But what is the value which I got? 33.1 I got. That means compound interest for total years. Compound interest for total years. Compound interest for total years. They are not in geometric progression. Compound interest for a particular year, they are in geometric progression. If the years are in, have a common difference. A1, A2, A3, A4. A1, A3, A5. C1, C2, C3, C4. Compound interest at the end of first year, second year, third year, fourth year. Suppose if I want compound interest for first year, it is given. Third year, if I want first scaling factor, then multiply for the next year scaling factor. Compound interest for total years, they are not in geometric progression. 3 important key points. In fact, there are 4 important key points. The first thing is A1, A2, A3, A4. If A1 and A2 is in the ratio x is to 5, y, A2 and A3 will also be in the ratio x is to y. A3 and A4 also will be there in the ratio x is to y. First key point, A1, A2, A3, A4. Amount at the end of the years, they are in geometric progression. Compound interest at the end of a particular year, they are in geometric progression. Compound interest for total years, they are not in geometric progression. I hope it is clear. Now let us solve some practice questions. Some practice questions. Problems. First one, CI for 4th year. CI for 4th year. It is 280. It is 280. CI for 5th year. CI for 5th year. It is 350. Compound interest at the end of 4th year. It is 280. Compound interest at the end of 5th year. It is 350. At the end of 5th year, it is 350. Find R percentage. Most of the teachers who do not have a good understanding of the concept, they will take that it is the initial value and final value. What is the concept that we have seen? CI1, CI2, CI4 and CI5. CI for a particular year, they are all in which progression? Geometric progression. They are all in geometric progression. What is a common ratio? Common ratio is given by scaling factor. 1 plus R percentage equivalent to 350 by 280. 350 by 280. 75s are 74s are. So R percentage is 1 by 4. 1 by 4 it is 25%. Why it is 1 plus R percentage? We have clearly explained in the previous slide. 10 is becoming 11. 11 is becoming 12.1. 12.1 is becoming 13.31. Multiplication factor is 1.1. 1.1 can be written as 1 plus 10 percentage, 1 plus 10 percentage. I hope this idea it is clear. Next one, suppose if the question is CI for 6th year, it is 980. CI for 6th year, it is 980. R percentage is 980. R percentage is, for example, I will take 25 percentage. 25 percentage. I want CI for 4th year. I want CI for 4th year. Another good question, sir. CI for 6th year, it is 980. And R percentage is 25 percentage. CI for 4th year. What is that we have discussed? CI for a particular years. CI for 4th year. CI for 5th year. And CI for 6th year. All are in geometric progression. CI for 4th year, 5th year and 6th year. All are in geometric progression. So 6th year, the value is 980. Here, the multiplication factor will be 1 plus 25 percentage. 1 plus 1 by 4. Here also multiplication factor will be 1 plus 1 by 4, 5 by 4. So answer will be x into 5 by 4 into 5 by 4 equivalent to 980. I hope the idea it is clear. 980. So x equivalent to 980 into 16 by 25. 980 into 16 by 25. Idea it is clear, right? So if the particular year, if there is a difference between only 1 year, directly scaling factor will be 1 plus R percentage. 4th year to 5th year. CI for 4th year, CI for 5th year, CI for 6th year. They are in geometric progression. This is 980. Common ratio will be scaling factor R percentage more. 1 plus 1 by 4, 5 by 4. 1 plus 1 by 4, 5 by 4. So this value into 25 by 16, it is 980. So that value will become 980 into 16 by 25. 980 into 16 by 25. I hope the idea it is clear. Now let me take the questions which he has asked me. The questions which he has asked me is, the question is, CI for, he was attempting one mock question it seems. CI for 13th year is 1024. 13th year is 1024. R percentage is 14.2857 percentage. Find CI for 10th year. Find CI for 10th year. Particular year it is given. Next question. CI for 3rd year. CI for 3rd year it is 2880. 2880. CI for 4th year. CI for 4th year it is 3456. 3456. Find the SI for 4 years. Find the SI for 4 years. I am just writing all his doubts, sir. Next question. CI for 2nd year. CI for 2nd year, it is 320. And CI for 4th year, it is 2000. 2000. All uses one common concept. CI for 3rd year, how much? CI for 3rd year, it is how much? Once you understand the concept, all these problems are very easy. Do not fear if you see this kind of questions in you. These are very, very fundamental of compound interest. Fundamentals of compound interest. Now first, CI for 2nd year is 320. CI for 4th year is 2000. Already we discussed CI for consecutive years. They are all in geometric progression. CI for 2nd year, CI for 3rd year, and CI for 4th year. And CI for 4th year. All are in which progression? They are in geometric progression. What I want CI for Third year I want, if ABC are in geometric progression, ratio it is the same. So second term by first term equivalent to third term by second term. B square equivalent to A into C. B equivalent to root of A into C. So root of 320 into 2000. 4 zeros are there, outside 2 zeros, 32 2s are 64. CI for third year, it will be 800. CI for third year, it is 800. The students who know this concept that CI at the end of a particular year, consecutively, they are always in geometric progression. Second year it is given, third year it is given, fourth year. Second, third and fourth. So third is nothing but the middle value. Third is nothing but the middle value. Second is given fifth, eighth is given fifth. That is also the square root. Second is given, 12th is given, seventh year. That is also the square root. As long as the time difference in the particular year, it is same, it is always middle value is the geometric mean of the extremes. So B equivalent to root of A into C. Answer is 800. So compound interest at the end of second year, at the end of second year it is 320, at the end of fourth year it is 2000. So at the end of third year it will be 800. It will be 800. Now see here. This one, CI for third year it is 2880. CI for fourth year it is 3456. It is 3456. These 8 is becoming 6. Which multiple of 8 I will get 6? 8 2s are 16, or 8 7s are 56. Let me take 20%. What is 20%? 1 by 5. So 1 by 5 of 2880. 5 5s are 25, 38, 5 7s are 576, which is 576. 5 5s are 25, 35, 5 7s are 35, 30, 576. 576 is 3456. So R percentage, we got it as 20%. 1 plus R percentage equivalent to 288, 3456 by 2880. All that we don't require. We have already done the rightmost non-zero digit. R percentage is 20%. So these were CI for 1, CI for 2, CI for 3, and CI for 4. CI for 3 it is 2880. So it will be scaling factor 6 by 5. It will be scaling factor 6 by 5. So compound interest for the first year. Compound interest for the first year it is 36, 36, 80s are 80 into 40. 80 into 40. It is 3200. Compound interest for the first year. CI1, CI2, CI3, CI4 all are in geometric progression. What is the common ratio? Scaling factor, which is 1 plus R percentage. I got 20%. 1 plus 20% is from here to here into 6 by 5. From here to here it is into 6 by 5. From here to here. Or CI for third it is given. So P into 36 by 25 equivalent to 2880. 36 into 80, it is 2880. 80 into 40 is 3200. Compound interest at the end of first year is 3200. In the first year, CI and SI both are same. So SI for first year will be 3200. For 4 years, it will be 3200 into 4. Answer is 12,800. Answer is 12,800. I hope the logic is clear. Very simple way of solving it once you understand. Sir, how I did? I don't want my students to solve like this. Doing these 1 plus R percentage equivalent to 3456 by 2880. It is time consuming. This is 8 and it is 6. 8 multiplied by which number I will get 6. 8 2s are 16, 8 7s are 46. So first I tried for 20% more. So anyway, it will be definitely 20%. See, approximately it is 2800, it is 3400. 2800, 3400. Difference is 600. 600 out of 2800. Answer should be around 25%. So it has to be 20. There is no question of being 70. So into 6 by 5 into 6 by 5. CI for the, in the case of first year, simple interest and compound interest both are same. In case of first year, simple interest and compound interest both are same. CI for first year we got. If CI for first year we got, SI for first year it is also we got, but I want for 4 years. In case of simple interest, interest remains the same every year. So it is 3,200 into 4 is 12,800. Into 4 is 12,800. Now I am sure you can solve this question. It is 13th year. 13th year. I will use a different color, sir. So these CI for 10. It is CI for 11. CI for 12 and CI for 13. CI for 13 is 1024. 1024. So from here to here, scaling factor will be 8 by 7. From here to here, it will be 8 by 7. From here to here, it will be 8 by 7. Are you all with me? 8 8s are 64, 64 8s are 512, 512 2s are 1024. So answer will be 343 into 2. 343 into 2. Because this will be 1024 into 7 by 8 into 7 by 8 into 7 by 8. 512 2s are. 512 2s are. I hope this concept it is crystal clear to you. Do not fear if the questions are like this. It's very, very easy questions if your concepts are clear. What is the concept? Concept is CI for the consecutive years. They are always in geometric progression. They are always in geometric progression. Amounts at the end of consecutive years, they are also in geometric progression. They are also in geometric progression. So this is the doubt asked by a student. To explain this doubt, these are some of the questions which I took it out from a standard arithmetic book so that you will understand it. I hope this concept it is clear. Now let us get into our problem solving. This was the doubt asked by a student. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free AMC.